Although science is the best way to come up with accurate explanations for how the world works, not all scientific investigations are created equal. Some are better than others. There are a couple of ways of measuring how good a scientific investigation is. Two terms that are often used are reliability and validity. Reliability is a measure of how repeatable an experiment is, where the results are similar when the experiment is carried out multiple times. But perhaps more important than this is validity, which is a measure of how correct the results of an experiment are. A particular experiment or investigation can be internally valid and externally valid. Internal validity is about whether the design of the experiment follows the standard steps of the scientific method and whether the process followed by the experiment makes logical sense. External validity is about figuring out whether the conclusion from the experiment is the real explanation for the phenomenon in the wider world. It examines things like whether there might be an alternative explanation for the result. If your goal is to make your result as close to the truth about the world as possible, then you need to improve your validity as much as you can. Most scientists are pretty successful making their experiments internally valid, but external validity can be harder to achieve. In this lesson, we're going to take a look at a few ways you can improve the validity of your experiments. There are a number of ways of improving the validity of an experiment, including controlling more variables, improving measurement technique, increasing randomization to reduce sample bias, blinding the experiment, adding a control or placebo group. Controlling more variables is about making sure as few things as possible change during the experiment. An ideal experiment is where one thing is changed and the result is looked at. Everything else should remain the same. So, for example, if you wanted to know how fast balls of different masses will roll down a particular hill, you would change the mass of the ball and keep everything else the same. You'd keep the material of the ball, the point of release, the measurement location, the humidity of the air, and height above sea level, and anything else you can think of, the same. The more you keep the same, the more likely it is that your result will be valid. Measurement technique can also be improved. Perhaps instead of measuring something by hand, you could use a computer and electronic sensor. Or perhaps instead of having one person measure the results, you could have multiple people take measurements and compare their answers. Increasing randomization is a way to reduce a particular validity problem, sample bias. That's when the samples being investigated are not a representative sample of the population. For example, say you're testing for the effect of a drug, and your trial contains mostly white males between 20 and 30 years old. That would not be a good sample due to the lack of breadth in age and gender. Or perhaps you are testing weight loss drugs on people who are of a healthy weight already. Increasing the randomization of the sample will reduce this problem. Blinding your experiment is where you hold back information about the experiment that might affect the results. For example, if a person knows that an experiment is about cold symptoms, a person may start noticing apparent symptoms they wouldn't normally have noticed. Or if a person knows that they took a placebo or a fake drug, it may affect whether they perceive any difference in how they feel afterwards. A single-blind experiment is where the participants do not have information that could skew the results. A double-blind experiment is where both the participants and conductors of the experiment are not given information that could skew the results. And a triple-blind experiment is where even the people analyzing the data don't have information that could skew the results. They are not told which piece of data is which, or even what the data is about. Adding a control or placebo group is about having something to compare against. For example, if you are testing a drug, the only way to know whether the drug is truly effective on its own merits is by comparing it to a fake treatment, or placebo. Patients will often report improvements when they are receiving any kind of treatment, even if that treatment isn't really doing anything. A truly effective treatment is one that shows results above and beyond the results achieved with a placebo. Something similar is done in non-medical experiments where an outcome is compared against the control. For example, if you want to know the effect of increasing the amount of light available for a plant, you have to compare this to a plant that receives the original amount of light. That second plant is known as the control. Validity is a measure of how correct the results of an experiment are. Internal validity measures whether the process follows the scientific method and shows anything of value. External validity measures whether the conclusion of the experiment is the real explanation of the phenomenon. You can increase the validity of an experiment by controlling more variables, improving measurement technique, increasing randomization to reduce sample bias, blinding the experiment, and adding control or placebo groups.